All right, hey, first period geometry. This is the second half of the notes that we went through yesterday, or we started yesterday. We got through 07, and you should have maybe started on this for homework assignment, but we'll go through the notes for 08 in this video, and you should be able to add this onto the same sheet of paper for your homework, and then we will turn that all in on Monday. So we did ordered pairs yesterday, and we talked about plotting points, and then we also talked about graphing lines. So when you graph lines, we have to have it in y equals mx plus b form, and then you start at the 4 and you use the slope and you go down 1/1 to graph the line. Okay, so we're going to kind of use that same thought process to do example 3 here, and it talks about systems of linear equations, and a system is usually like two linear functions that are going on at the same time, and it says solve each system by graphing. Okay, so when we're solving the system, we're going to end up with two lines that are intersecting, and we're trying to find that place where they intersect each other. Okay, so these two functions are already put in y equals mx plus b form, so we just have to graph them. Shh, hey guys. Shh. And so we're going to start at the +3, which is the y-intercept, this guy here. And then the slope is -1, so we're going to go down 1/1, down 1/1, down 1/1. We're going to draw our line, and it looks something like, ooh, that was a terrible line. But anyway, that's what my function looks like. And then I'm going to graph the second one by starting at -3. That's this guy. And then up 2/1, up 2/1, up 2/1. And we have this guy here, and we have him graphed. And we're looking for the place where they intersect each other, which is this one right here, and that coordinate is about 2, 1 is where those intersect. It says determine whether each system has no solutions, one solution, or infinitely many solutions. This one has one solution, okay? Now, graphing is not really the ideal way to go about finding that solution because, for example, you might have, them cross at a really awkward place, and then, you're having to try to figure out what decimal place they cross at. So for that, instead, we're going to use substitution and elimination to find those exact points. Not to mention that graphing is kind of a problem anyway because, it takes a long time. So, we'll, down below here, we'll do some examples of substitution and elimination where we can find this answer without actually having to graph. Okay. Part B, though, we're graphing again, and these are not ready to be graphed. So I'm going to start this guy, and we're going to fix him so that he has the y solved for. We want to get the y by itself. So we're going to add the 2x over. And 2x you cannot add to the 6 because one has an x and one doesn't. So we're just going to leave them separate. We have y equals, and I write the 2x first, plus 6, and now he is ready to be graphed. Okay. This second one is a little bit more work than that even. We have to get the y by itself, but we're going to bump the plus 6x to the other side. Plus 6x. Okay, I'm going to write that down here. So 3y is left on that side equals 6x plus 9. And we have to do one more step, which is divide by 3 on everything. And we have y equals 2x plus 3. And that's going to be the one that we're graphing. So we're graphing these two functions here. Okay. Now, one thing that you will notice about these two functions is they both have the same slope, okay? And both having the same slope means that they are going to be parallel to each other, and we'll see that here in just a second. So the first one, we're going to start at 6, and we're going to go up 2/1, which puts a dot there, and we're going kind of off the grid, so we can go instead down 2/1 this way, and then we have our line there, okay? So that's what he's going to look like. And then the second one, we're going to start at 3, instead, and we're going to go up 2/1, up 2/1, or we can go down 2 to the left one. If I'm going too fast, please pause. And we can see, just like we said, those two lines are going to be parallel, okay? The question that it asks here is no solutions, one solution, or infinitely many solutions. If those two lines are parallel, they will have no solutions. So you can either do a circle with a line through it, or you can just say no solutions. And that will be, and so they have no solutions because they're not touching each other is why there's no solutions, okay? So let's move on to the next one where we do substitution, elimination. Substitution versus elimination, you can do either one of those processes on any system of equations, but some of them are easier and ready to go for one process over the other. Like A is easier to go ahead and just do it using substitution because the y is already solved for. Okay, substitution, you have to have one of the variables solved for. It doesn't have to be y. It could be x, but you have one of them solved for. And then this negative 4x, we take him and we plug him in where the y is. Okay, so this is what it looks like. 2 times negative 4x plus 3x equals 8. So just this guy right here, we plopped in the negative 4x. And then we just simplify. So 2 times negative 4x is negative 8x plus 3x equals 8. Okay, and then we keep solving. So negative 8x plus 3x is negative 5x equals 8. And then divide by negative 5. And that gives me a really ugly answer, negative 8 over 5. Or if you want to write it as a decimal, it's negative 1.4 is what x is. Okay, now we're not done yet. We've got to go back through and we've got to solve for y. And you have options. We can solve for y. We can plug in x either here or here, but the easiest one to do is probably the top one. So we've got y equals negative 4 times, we're going to plug that number in for x. So we've got negative 1.4 in there, and 4 times negative 1.4 is going to be a positive 5.6, okay? So our answer is going to be negative 1.4 comma 5.6. We write it as an ordered pair. And really what that thing is doing for me is that's saying if I were to graph these two lines here, that would be the place where those two lines would cross, okay? Now, it's probably not, I mean, we probably wouldn't be able to identify that exact point if we were to graph them, right? We wouldn't probably guess that it was negative 1.4 comma 5.6 exactly. So that's why substitution and elimination are kind of a little handier to use, okay? Part B, use elimination to solve the following. So here we want to decide whether we want to eliminate x or eliminate y. Sometimes it will be evident that one is easier than the other, but in this case, you know, we can use either one or eliminate either one. Let's go ahead and eliminate the x's. So we want to get the 3 and the 4 to be the same number. And so we look at 3 and 4 and a number that both of those numbers go into. So we're going to switch both of them to be 12. And in order to switch them to be 12, we have to take the 3 and multiply by 4. And we have to take the 4 and multiply by 3. Okay, but when we do that, we wanted them to eliminate. So one of them has to be 12 and one of them has to be negative 12. So we're going to switch, and it doesn't matter which one is negative. Let's just do the bottom as a negative. So that way when we multiply through, one ends up being 12 and one ends up being negative 12. Okay, but if we multiply by 4, we've got to multiply all 3 of those pieces by 4. So this is going to be 12. This is going to be 12x plus 20y, if we multiply by 4, equals 28. And then the second one, we do negative 3 times 4 is negative 12x. Negative 3 times 2y is negative 6y. And negative 3 times 0 stays 0. And now we're allowed to eliminate. The 12x and the negative 12x go away. And then 20y minus 6y is 14y equals 28 when I add those two together. Okay? Divide by 14, and we get y equals 2. And that's part of the answer. Now we plug back in. And we have options. We can plug back in wherever we want to. I'm going to plug into this one right here. Since it's equal to 0, it looks a little easier. So 4x plus 2 times, we're going to plug 2 in for y. Thank you. Equals 0. And 2 times 2 is 4. To solve for x, get the x by itself, I'm going to subtract that 4 over to this side. Again, if I'm going too fast, please pause it or, slow down and whatever you need to do. Divide by 4, x is going to be negative 1. And then we write that as the ordered pair, negative 1 comma 2. And that, again, is the point where these two lines would cross each other, okay? One more thing that I'm going to add that you might see, like up here, we said that these two lines were parallel and we got no solutions. When you are doing substitution and elimination, you will know that you get no solutions when something funny happens. I'm going to talk about that real quick. So graphically, you have 3 options. Either you have 2 lines crossing each other somehow, some way where you have one solution, And that just looks normal. That looks like this and this when you do substitution and elimination. So it's just normal. You'll get two answers, one for X and one for Y. If you have two lines, though, that are parallel to each other, that's when you get no solutions. And what will happen there is when you do your elimination or substitution, you'll end up getting to a point where you stop and it looks like 0 equals 1 or 0 equals 4 or something weird that is not true. Like 0 is never equal to 1. Whoop. Is not true, so you end up with no solutions, okay? Then you will end up with infinitely many solutions if you have two lines that are lying exactly on top of each other. And that happens when you have infinite solutions, or when you're doing substitution and elimination, you will get to a point where you have 0 equals 0, which is always true, right? 0 is always equal to 0. Or you might end up with 4 is equal to 4 or something like that, where it's the same on both sides. And that is when you have infinitely many solutions. It's always true. So this is the stuff that you're going to get when you do substitution and elimination versus graphing, and that's how you'll know whether it's one solution, no solutions, or infinitely many solutions. Okay? And you will have some of those on your homework assignment. So again, add this homework assignment to the page that you already have, or if you need to get a new page, that's fine, whatever. We'll just staple them together, and we will turn all of those in tomorrow. I'm going to leave graph paper with my sub, so you can get graph paper from her if you need to graph some things, okay? There you go.